Hey everyone, this is Barry here, coming at you again with a little bit more absolute value function work. Today what we're going to have going on here in our Nearpod is instead of having a graph and pulling information from that picture, I'm actually going to have an absolute value function here and then create the graph. So I'm kind of working backwards from what we've been doing here recently. Before I talk about that, I want to go ahead and refer back to some of the information we've talked about previously. When we have absolute value functions, we have a common general form for an absolute value function. Y is equal to a times the quantity of the absolute value of x minus h plus k. We know that h comma k is our vertex. Sure, on a graph it's going to be x comma y, but within that function, it's the h and the k that we're looking at. And then we also know that A is going to be the slope to the right of the axis of symmetry. The axis of symmetry is that imaginary mirror that we can put right down the vertex, vertical line that we can put right down the vertex. That means that we should have points in equal locations on the other side of the mirror, on opposite sides of the mirror. So what I'd like to do here is take a look at this absolute value function. We have y is equal to 2 times the absolute value of x minus 3 plus 1. And like when we have a picture up here, I want to go ahead and make sure that the very first thing that I do is go ahead and find the vertex. Now this could be slightly tricky. I mentioned a bunch in the last Nearpod the fact that the letter H, of all three things going on here, the A, the H, and the K that we're going to eventually find in this function, the H is probably the one that causes the most confusion. I want you to kind of think of it as the following. So inside the absolute value right now, I have x minus 3. And I'm going to try to figure out what value of x would make that equal to 0. That would probably be the best, easiest way, and the way that's going to probably lead us throughout the whole semester and the whole class, because this type of a concept is going to come up very often, where we have a minus sign in a function, or a minus sign in a common general form. So if I think about this, x minus 3 is equal to 0. What value of x would be something we could plug into this equation to give us the answer of 0? And hopefully we all understand from Algebra 1 we would add 3 to both sides, and we get x is equal to 3. So x is equal to 3 here. For us, in that function up here, what that means for us is that h is going to be also equal to 3. That's probably the hardest one to take from that function and figure out what it is. The other ones are pretty straightforward. Right here on the back end I have a plus 1, and the k value is right there. That's going to be 1. Pretty straightforward there. And then finally, the last thing we could take a look at is the letter A. The letter A will be this coefficient in the front of the absolute value here. And in this problem, you can see pretty straightforward here that A is equal to 2. So we have our vertex, we have our A value. We can go ahead now and graph this absolute value function. First thing I want to check out is the vertex. The vertex is h comma k. We figured out that that's going to be 3 comma 1 for our vertex. 3 comma 1 is our vertex. I'll put a dot over here. I'll go from the origin 3 and then up 1. There is our vertex. Now at that vertex we understand a couple things. The one thing that we understand the most is that there's an imaginary line running through that vertex with a vertical line. So the dots that I'm about to draw are not actually part of the picture, but they can certainly help me draw the rest of this picture. Next up, I want to use that A value. The A value here is 2, which means the slope to the right of the the slope to the right of the axis of symmetry would be 2. Now, with the slope of 2, hopefully we can kind of work back and understand that lowercase m slope is 2, but we might think of it better as a fraction, where it would be 2 over 1. 2 over 1, those numbers right there are both positive, which means we're going to go up 2 and to the right 1 from the vertex. So we're counting from the vertex and we're going to go up 2 to the right 1. I'm going to put as many dots as I can put on this graph, and then try my best to connect the dots. So I'm going to go up 2 to the right 1, up 2, right 1, up 2, right 1, as many times as possible. And at the end of that, we know that this part of the absolute value would extend on and on and on forever. So I'll try my best here to draw a line. Try to use a different color here as well. So I'll put an arrow at the end of that part of this absolute value function. From previous videos, you should be able to finish out this absolute value one of two ways. You could say to yourself, well, I know that if the slope over here was 2 over 1, or the number 2, the opposite has to occur on the opposite side, so I would have a negative 2 slope. The other thing we can do is just say, hey, this is a mirror, so if I reflect it across the mirror, I should be able to get that. But either way, that's up to you. I'm going to go ahead and count out. So the slope being negative 2 on this side would allow us to go from the vertex up 2, 1, 2, and to the left 1, up 2, and to the left 1, up 2, left 1, so on, and so forth. Hopefully, I'm going to stop here for a second. You realize that if we're taking a look at our axis of symmetry, there is one spot between that dot and that dot to the axis of symmetry. There are 2 spots away from the axis of symmetry here and here, 3 and 3, 4 and 4, and that pattern should continue. So if you wanted to just say to yourself, hey, what would it be like on the other side for the mirror? Just count it out and say, well, there's 1 spot here, there's got to be 1 spot here also. You could do it that way also. I'm going to go ahead and just put the line on here. Obviously, grab a book or a ruler if you really want a straight line. But right now, you can see my V. Might not be a terrible idea. You don't have to do this, but might not be a terrible idea to go ahead and erase that imaginary line that we put in for the axis of symmetry, just so we can purely see up there the letter V for our absolute value function.